Forward. Oh, thanks. I have two talks that have been rolled into one. So I'm actually going to kind of wrap up and give a futures on decision support, then hop right into disease pattern discovery as well following that. So without further ado, let me just talk right into clinical decision support systems. I'm a radiologist, as you have probably heard from some discussions earlier, so I have a background in computer science, but this focus is really going to be toward decision support and other aspects of clinical decision processes inside of radiology. So one of the things I'm going to talk about here are first the opportunities and challenges around clinical decision support, where it's at today, where it's at tomorrow, and again, specifically the tomorrow part will be within radiology. So just to kind of bring all this home, there's a lot of different names for this. There have been over the years. There probably will continue to be quite a few. So if you hear things like evidence-based, knowledge-based, expert-based, rules-based decision support, it's all essentially the same thing. And the way it's tied together is methods to be able to hold knowledge representation. And typically this is done today with the computer science paradigms that we have by constructing knowledge rules. At the high level here, you can think of this like back in the 80s as artificial intelligence. And there were a lot of different ways to define AI through various methods, but one of the things you can think of is there's a strong and weak artificial intelligence. And what do I mean by that? Examples out there would be a perfectly independent automaton that would do anything you told it to, kind of to the corollary of what Paul was showing before about why flights, you feel safe on flights. There are air traffic controllers there, and they're humans that have tremendously automated systems, but the systems aren't completely automated. Weak AI are things more like calculators, or as I like to call them, cognitive prostheses, for those times when you need a little assistance in remembering things or trying to do a particular mental task. The point of this is that, in my mind, healthcare decision support does not necessarily need strong AI to aid in many of these data-rich, data-deep challenges, and I'll talk a little bit about those. So if you're discouraged by the fact that decision support, the holy grail, isn't there yet, that doesn't mean that you can't do anything, and that doesn't mean that industry shouldn't participate in this. If we look at the opportunities that are out there and the way that people have measured their implementation of decision support, there's typically three metrics: patient safety, and has it improved that? What has it done for the quality of care? And that's a difficult thing to measure, the end point of that. And also, what has it done for the efficiency of healthcare delivery? The polite way to say is it's saving money. If you look at the challenges here, there's quite a few. There's knowledge management, which was talked about a number of times in some previous presentations today. I think it's even a challenge to figure out what knowledge is, let alone to figure out how to discover it, and then how to hold it, and then how to change it, and how to apply it. So that whole concept of knowledge management is a challenge. This is very dependent upon EMR. If you looked at a study from, I think it was one of the magazines in healthcare IT, that asked CIOs in the United States what was their most important thing that they wanted to accomplish in the next 3 to 5 years. It was electronic medical record, but that survey was done about 8 years ago, and if you look at it, it's still there today, high on the list of things that want to be done. So without EMR and without the ability to gather information and disseminate it electronically, it's going to be a challenge to do decision support. Poor economics in the systems and the failure of these systems to fit naturally into routine care have created a general reluctance of healthcare workers to these concepts. Not across the board, but there is always that percentage that are going to be reluctant. This is what I'm not going to talk about, which is all the stuff that decision support does today, but you'll have it in a copy of this presentation. And these are things that you're probably all familiar with. I'll just make one note here. Prescribing decision support systems seems to be the one that caught the most attention in the press and lay press and everywhere, how decision support can really help out here. Another area, too, is practice guidelines, which I'm going to talk about, appropriateness criteria. So this is the old paper method of at least trying to put protocols and methodologies in place, forgetting about how you're even going to deploy it or disseminate it. So let's look at radiology decision support. What's the problem with the system today? Currently, the knowledge is unmanageable. So trying to make radiology decisions, either for radiologists or for clinicians, is getting more and more difficult. The knowledge transfer is inaccurate, how we push information back and forth and how we acquire it between our colleagues. The feedback that we get back is anecdotal, so when we find out that someone's not doing the right studies or that we're giving the wrong diagnoses, it's typically a hallway discussion about how that happened. There's no system to monitor the effectiveness of the system in place. So the result is highly variable human decision-making. We're not auto-correcting and self-correcting in our processes or even comparing amongst ourselves typically. And it's all only going to get worse. With molecular imaging and all of the new imaging techniques that are out there, It's no longer just a list of 10 things or 50 things to choose from. It's going to be hundreds and thousands of choices for medical imaging. Well, the savior may be the American College of Radiology appropriateness criteria. Now, you'd think, since this has been around since '94, why, if it's going to be something that's going to save us, hasn't it done anything in the last 10 years? Well, let me explain what this is. There was a push from the United States federal government toward the college to start to control some of the costs back in '94 of these rising healthcare dollars, and specifically toward medical imaging. And they said, well, the college has probably got the most knowledge about what should and shouldn't be done, and so let them define with other subspecialties what would be appropriate and not appropriate to do. So they created expert organ system panels. There's 9 in diagnostic and 2 in therapeutic, made up of dozens and dozens of experts that culled the articles throughout all of the press and tried to make decisions based on these different exams which were appropriate and not appropriate for certain clinical conditions. It was a big, long, laborious process that still goes on. All of these people get this information. It's a modified Delphi approach to determine these numbers. They have to gain consensus. If they don't have 80% consensus, it goes back, it comes back, it goes back, it comes back. And at the end of this, you wind up with a 1-page per clinical condition that talks about what imaging procedures are appropriate on a scale of 1 to 10, or 1 to 9, where 9 is the most appropriate and 1 is inappropriate. So where is that at today? It's they're continuously updating this criteria. They're expanding this beyond the 1,000 clinical conditions that exist today, and also expanding it to the new modalities that are being created all the time, which is a challenge. But the current system is a book about that thick. And so the problem is that there's limited use of this. It's very hard to figure out the answers to the questions that you're trying to find. The good news is that there's a web service application that the ACR is currently in the process of trying to decide how they want to create this. So the concept would be they'll hold the information. If you want to query this with a web service as a decision support system or a order entry system, you can get an answer back to you whether that's appropriate or not. And we're meeting, I'm on the panel for that. We're meeting with some industry partners to talk about how they would want to deploy that and use that. What are the specific goals at Mass General around decision support? Well, our goal is to provide ordering physician decision support, radiologist decision support, and I'll talk about that. It's kind of a new concept, and monitor the effects of these things on utilization and quality. Why are we doing this? Well, we're doing this because of this hockey stick. In '97 or so, these are the annual procedures that are being done at Mass General Hospital, and it stopped in 2003, and it's actually about there now. It's just taking off. And no one likes that. The radiologists don't like that. The delayed patients don't like that. The physicians don't like that. And clearly the payers don't like that. So the question here is, of this area on the top of this cliff, is this all fluff? Is this something that happened recently? Is this right? Is it wrong? And the problem without this kind of decision support tools is no one's able to answer those kind of questions. The decision support system that we want to put in place will do the following things. We want to have contraindication screening. So if someone's not to have the procedure for safety's sake, we will disallow it. We also want to gather the appropriate information at the time we're asking of the order entry individual, what is the appropriate protocol to perform for a specific examination. We also want to tell them that there's a previous examination that's been done on this patient, maybe at another institution or another imaging center or ordered by another physician, that will probably give them the similar information. We're then going to use the appropriateness criteria framework to create some of this question-answer scenario to figure out, is this the best thing that they should be doing? We're going to take those difficult numbers and we're going to color code them so that we get a kind of stoplight approach to be able to go on or not go on, and we're going to give them imaging alternatives also based on the appropriateness criteria. The next challenge will be, we have one order entry system that's in place at Mass General for radiology for about the past 4 years, but there's many others in our network. So we have to make the decision support system removed and snappable modular from the order entry system so we can snap it into other CPOEs that we have throughout the network. So here's an example of the integrated solution of what it looks like. So I get on, I log myself in, I put in the medical record number of the patient, and up comes the options that I have for ordering different procedures within radiology. These is by modality selection, and if I say I want a CT of the head, now I get challenged with a series of pull-downs. And this is all, we tried to contain everything all inside of one 800 by 600 screen. Sometimes it scrolls a little bit, but it's pretty much there. We ask questions up front to figure out what's contraindicated and how to protocol, and then we say you must fill in from this area one of the indications or the reason why you're getting the exam. What are the symptoms that the patient is presenting so that we know how to help you in your decision process. We then come back with that information, and a lot of the times the physicians are correct, so we just let them go on, or they're doing a procedure that isn't under the scrutiny of decision support. Maybe it's a lower cost thing at this time, and we let that go through. But if, for example, there's a case where someone orders a CT of the head for an indication that has a 5 as an appropriateness criteria, we would stop them here. We would give them their alternatives. And since medicine is really shades of gray, or I guess colors in the spectrum here, we're not going to say yes or no. We're going to just give them this added information to help them to decide here, well, MR appears to be better. And they can click on any of these and find out why that statement is true based on information and evidence that we have. We've also validated these things with our colleagues outside of radiology to make sure that they agree with these numbers forward too, so they don't argue about them later. But we're actually allowing them to go in and then change their order to another procedure. Not necessarily a cheaper procedure, just a procedure that we considered by the appropriateness criteria to be more appropriate. We then let them go forward and schedule this, so here's some perks that they get. The patient that's in there, they can actually go into the scheduling system and then click in and select the location and where and what they want to have and what time. The statistics that have come back from this, now as I said, we had the CPO system running for 3 years, but decision support just came in 6 weeks ago. So I've been preparing this for about the last 9 months and dropped it in. Over 3,000 ordering physicians are currently using the system for the last 6 weeks. There's not a lot of grumbling, so they must not hate it too much. And there's over 50,000 exams that have been ordered on the system in the last 6 weeks. And the other important statistic that I can just give you at this level is to say that over 20% of the orders have been modified by decision support guidelines. Is that good? I have no idea. No idea. It's too early to tell. So we need to find out what we did to these folks by changing these numbers. But clearly there is some things where the numbers were coming out very low. So assuming that those were fact and those were correct, there were people ordering inappropriately to the tune of about 1 out of 5 exams. So more information, stay tuned to see what comes back from that analysis. It's going to take a while. If we look at radiologist decision support, these are the kind of things that a radiologist wants to be able to have at the time that they're diagnosing. Atlases, differential diagnoses, disease references, other information from outside, protocols on how to recommend for certain follow-up to procedures, your own notes, critical alerts. And the goal here for us was to tie this into voice recognition, because it's not only what the radiologist is seeing, it's what they're saying that gives you a lot of the information about what they're thinking about. So this is really, in my mind, this cognitive prosthesis. So if you use voice recognition, basically you're taking the transcriptionist out of the loop and you're putting the computer in to do speech recognition right at the time that you're looking at the images. The big advantage here is that for the first time, and probably the only time, you'll actually have the text, the things you're saying in a text form that the computer can understand, and the images available to you right there before you're ready to close the whole case out. So the goal is for us to take advantage of that situation by applying some logic at the time. So we've taken a product that I'll talk about called Lexamer that does analysis of natural language understanding of text and dropped it through and then use that as hooks into medical knowledge, bring that information back as a separate window for the radiologist to be able to see while they're talking. So you can imagine as they're talking about this lesion that they see, they're not defining it in etiology sense, but in a morphologic sense and an anatomical sense. So we've gathered this information that they're talking about. We realize that they're probably short on some differential diagnosis. So we give them a choice to select from the differential. They do. Then we give them the choice to select on a particular disease here, FIO, and then from there they can dive into more information as they want to. So it's really trying to not take them out of the loop, not to interrupt them if they don't want to be, but to watch where they're probably running short of information and try and aid them, as I say, as a cognitive prosthesis. I'm just going to step through. I've got 5 minutes, so this is going to be amazing. Okay. Critical alerts, notification of findings and recommendations is another area that we're focusing on. So if we can use the same system to take this gigantic report that a radiologist wants to get to a busy surgeon and call out these essential points, we can basically let this individual know through page and different methods. And we can also watch to say, well, we said a brain MRI is needed within 7 days. 7 days went by, and we need to notify back now to the ordering or to the reading interpreting radiologist that this wasn't performed. All right, decision support timeline. We're basically right now in the stage where we're creating practice guidelines, ordering, decision support, and this cognitive prosthesis. But what's to come after this is much more accurate image computer-aided diagnosis, and then clinical knowledge rule generation is still ongoing, and then finally the goal will be diagnostic and therapy planning. Let me step right into clinical data mining and talk about the goals here. This is really a spectrum that we're going to be presenting. So there's clinical conditions that we want to query for. We may want to just grab information, or the Holy Grail, we want to pull out knowledge and knowledge discovery. So the challenges here are the data sources coming from everywhere inside of an institution. There's very limited structure, and the ontology itself is embedded inside of the report. So you have to figure out what it is that this sentence is saying. Digital information, the digital format is important for all data, so you have to convert everything to digital. Everyone's still probably got some paper inside their system in locations. And then you have to structure it. So you have to obtain as much coded information as you can, discharge summaries with codes, ICD-9, CPTs, but you're probably going to have to do some level of NLU. And you want to create a widely accessible repository once you've done that. So we have a system that's been in place. I have nothing to do with this other than a user of this, a research patient data repository that's got text data that lets us go in and get this information of 2 million patients, 500 million data points, 750 faculty use this, and they can do their own independent queries. And of note for me is that the radiology image display is in pilot phase, but we currently have no way to query into the radiology information, so we can't ask questions. Now, we want to do that, so we want to query into the radiology reports and the radiology images. The problem is there's absolutely no structure, and we've got an awful lot of data. We have 2 million patient demographics, 6 million radiology interpretations or reports, and 150 million radiology images. That's about 100 terabytes of data. So the first thing we do is we want to go in and grab some structure. So we created, as I said, this product called Leximer, which we go in and do some natural language understanding. I won't talk about it right here so I can get through this presentation without more numbers coming up at me. But what it can do is it can detect an observation of a positive finding in the report and also a recommendation for further imaging. And so let me just show you how very, very crude overhead kind of a Flintstone diagram of how it works here. Basically, you drop a report in, and it's going to say there's a finding and a recommendation, and we also have the added value of saying what that sentence is. The next challenge will be to figure out exactly what it's saying inside there, and I'll talk about that in a minute. But if we just take this data, we can maybe add to this question of saying, are we doing a lot of stuff that's negative now, or were I doing stuff that we self-referred? Did we say to do another CT or an MR on this patient? We really didn't know that before. So the first thing we did was we ran this across 3.5 million reports over 8 years, and we said, what's the positivity rate over those years? How many positive findings inside of reports do we have? And it stayed right about the same, about 70%. And then we said, how many times did we self-refer or refer more imaging procedures? And it stayed the same at about 7%. So the big number that went up, even though that went up, the volume went up, the positive rates and the recommendation rates didn't change. Now we can do further things, like we can look at modalities. So this is a big web system that we can go in and look at all this data. But I'm just going to ask the question now, for a given modality, what is the positivity rate and the recommendation rate? And this is kind of interesting. This is all over the place, and we could talk for quite a while about this, and I won't, but it's different. So, for example, mammo, perfect. You know, it's supposed to be low because it's a screening device. CT is now morphing into a screening device, so it's changing also on its positivity rate, which is lower. And we're constantly recommending at the end of CT to do something else. So those numbers have changed over time. We also wanted to look at practice pattern inconsistencies. So ordering practices of referring physicians, are they different? Recommendation practices amongst radiologists. So who's the outlier out there? And give this information back. So we can run this a variety of different ways, and we can look at things like, we ran 5 clinicians ordering MR of the knee, and we looked at their positivity rate mapped against their recommendation rate. So how many reports that they ordered had positive findings, and how many had recommendation rates for further imaging. What does this show? I have absolutely no idea whatsoever. That's the fun of data mining, is you don't have to know what the question is. You just got to figure out what the answer is after you get it. So what happened here is that they're all sitting around this 95% positivity rate, which was the same for the group for MRI of the knee. But there was one, for some reason, that was dropped way down low. His findings were consistently far lower on the exam. And when we looked in further, that one clinician was not a orthopedic surgeon. Maybe that stands to reason. So maybe this is a way that we could look to see who needs education from an ordering process, or who needs more decision support tools, We also looked at interpreting radiologist reports and looked at the chest CT of 8 radiologists' orders over a year, and we looked at their positive findings and recommendation rates. The bulk of them sat up in this high range, but 2 of them sat down low. Why? These folks, I didn't know at the time, were 2 ER docs that were reading chest x-rays. And so maybe it's because they saw our CT of the chest. Maybe it's because they saw different patients, or maybe because they read differently. Those are the kind of things we have to look at. Here's an example for thunderclap headaches for head imaging. So if for the indication of this, what are the outcomes and comebacks for these different procedures that we can do? And the interesting thing that we just ran the data, we found out that it's actually slightly different for females. And so is it statistically significant? I don't know. What does it mean? I don't know that either. That's the stuff that we have to figure out next. If we want to create even more structure, what we can do now is start to, as I say, describe what it is that these final sentences that have meaning to us are actually saying. So we've now extracted out structure in a hierarchical way to be able to represent this to ourselves. And now we can go in and query into a PAC system that we've reconstructed as a research PAC system and ask questions like ependymoma with a brain on MRI. We then structure that query and challenge that against the structured reports that we have out there, and we can get images back in kind of a Google-like fashion. We can do the same thing with the anatomical descriptions and query it anatomically because we have that method to be able to look up as well. So I can say I want to find things in this region, and I can get information back that way. So we can create even more structure by not just using the reports, but we can also now start to do some feature extraction. So we can use modern CAD today. We can grab information on future applications like sagittal asymmetry index. So is the brain larger on the left or the right? Is there a tumor detection out there? Is there myocardial wall thickening? Looking for a hypertrophic cardiomyopathy. And future imaging procedures like molecular fusion or 3D imaging. We can capture this information as feature extraction, which in my mind is essential for knowledge discovery from image data mining. Now we go back to the beginning here, and we can take this RPDR, this research patient repository, which has links into the clinical data repositories, and try and tie in this information that we now have in the 100 terabyte range sitting inside of our RISs and our imaging PAC systems. First thing we have to do is pull all those into PAC systems from the modalities, put that into a research image archive, put that into structured feature sets that I was talking about, and now have a structured image repository that this RPDR can query into just like it does the clinical data. And then if we add the genetics data repository that we were talking about earlier, now we can really start to do some queries. So let's look at the genetics and image queries and things that we could do. Real quick, the thing just to remember from the use of it, genetics and imaging. 1 minute. Okay, not bad, not bad. I have about 4 slides left. The genotype, obviously, you can find by genetic analysis, and it's really those SNPs. So what is it that the patient has in terms of SNPs? And when you run them through this filter of the penetrance of that expression, the developmental experiences they've had, and the environmental experiences had, out pops the phenotype, which can be identified in large part by medical imaging. So this is what you get based on what you have. And so now we can start to look at these different things and how they interact and relate. So from disease management, as we were talking about before, you can have a given phenotypic expression. So you have a disease, and you can now say, well, because of this and because of this finding, I'm concerned about one of the things that could be causing this, which would be this SNP, or this SNP, or this allele. And so you can work backwards and say, okay, what is the genetic composition of this individual that's creating this, and then figure out what the underlying disease is, and also therapy planning, what works for this person. You can go the other way, and you can say, given a phenotypic expression, so this person's father had an issue, and so we're going to do some genetic counseling, and we want to take a look at the genes. Well, now we know what to look for on imaging on this patient to see how they express themselves phenotypically. And when they do, you know, again, what the underlying disease is and therapy planning. There's 2 other quick things we can do here, and then I'm done. You don't have a 1/2 on your paper. Combinatorial analysis of expression and alleles. So this is a very interesting thing as we're talking about this massive supercomputer problem of saying, Well, we've got a lot of genes that are expressing themselves in a lot of different ways, and we have a lot of images that are expressing themselves in different ways. Wouldn't it be nice to say, if I could perfectly measure the thickness of the heart in every single patient's images that we've ever had, and I could also go through and mine all of the SNPs that we've had and the allele information that we have on these patients, can I just let this thing churn and say, okay, well, these SNPs are related to this thickness, and these SNPs are related to this thickness? And the answer is probably yes, and there's an awful lot of work that needs to be done in that area. The other area where we can combine these two together is targeted genetic analysis via non-invasive imaging, and this is molecular imaging. So now I can take an imaging moiety that's going to be able to show up on MR or CT, and I can take something that's going to tag and find a protein out there that's specific for disease, put it in the body non-invasively, let it run around, find its protein target in the prostate, say, and now I can image that and take a look to see that that's been actually reflected inside of the patient's development. So, last slide, promise. What do we want to do here? Well, we are up to the point where we have clinical image data repositories. We have genetic repositories. We're doing some report feature extraction, some image feature extraction. But what's going to come next is this whole concept of phenotypic and genotypic integration of a mining system. Molecular imaging is rapidly growing. And then finally, the ability to combine these together for disease discovery. And that is it. Good. Thank you very much.
So, comments from the panel. Let's start with Paul this time.
Well, a question on the why the hockey stick.
Oh, yeah.
One of the reasons that more orders is because it's there, so it's a mountain approach. And looking at your data from the data mining, one could ask a lot of questions. The true positivity, let's say, from an MRI of the knee, that could be at that rate because all other possibilities have been exhausted.
Right.
Or it could be totally confirmatory as maybe the PET scan high rate might be.
Right.
So the question is to figure out whether there's goodness come out of the test. So are you measuring what positive results led to, what results, positive or negative, led to a change in management as one way of measuring how many led up to it and what's the good of that one particular test order? Yeah,
the biggest problem, there's two main problems with the method that we're using, and it's because of the limited data. One, we only know what we know. So there's a lot more information that we just don't have. And this whole concept of radiologic-centric approach to giving decision support to radiology, absolutely wrong. It's flawed from the beginning. So we only have what we have, and we have to start somewhere. So that's where we're going. The second point is the end point is not necessarily correct. So did we save the patient's life? Was this finding, the question we asked when we created the system was, is this a finding that will change the patient's outcome? Yes, no, some way or another. So that was how we focused the expert system. But beyond that, what was the outcome and all of those issues? We don't know. So this was really our first tap into just asking this question, is this even significant, and is this something we should tackle? Good question.
Shankar, before you do that, could you pick up the microphone? I forgot to ask for that before. So you can use the microphone. It comes out of that holder.
It's on, I guess. Is it on?
Yes.
So the question I had for you was, I really think this is strong. It's very, very important to have these decision support systems of this kind. But they're all Boolean by definition at this point in time. There's a lot of statistical learning that needs to be done. There's a lot of Bayesian approaches that need to be employed in order to find out not just 0 or 1, but to look at probabilities and propensities and likelihoods. Are your efforts directed at using statistics in strong ways and statistical learning in strong ways to come up with decision support systems and then test them against your Boolean ones to see how valid they are?
This is about the most pragmatic approach to decision support that there is. And so the whole goal to start with was to take about 8 rules for about 3 procedures that were very expensive and stopping people from doing very simple things like ordering an exam twice in one day. And then you add a few more rules and a few more rules, and now I think this has grown a little beyond where we intended it to go, and now we have to do exactly that. And that's why we wanted to create the system that does NLU to say, are these even the right rules? I mean, is this coming out with what we think it is that the ACR is telling us based on their interpretation of reports and meta-analyses that happened over maybe 4 years ago? So the problem with a lot of this is you can't even keep up with the data, let alone be able to create a statistical model that would support What you're not really sure is the data that you want to put into it. So, very good point. I completely believe that that's going to be the solution. But I think the reason that's keeping us from that is we don't have enough variables to put in to allow for that statistical variability. It's almost like a yes or no is coming in, so it's hard to throw a lot of statistics to that. And that's back to Paul's point in the beginning. We need more data coming in to make these decisions appropriate.
John?
Yeah, one observation, one suggestion, one question. I think one of the there you go, covered all of it. I think part of it, response to the prior question, one of the reasons that Boolean works is healthcare is so screwed up that you don't need too much in the way of variables and logic to point out a drug interaction or a failure to follow up on a lab test or a variety of things. So
kind of like the weak AI point.
It's just really, anyway. The suggestion, Keith, is we're coming up on budget season, and a suggestion to you is to, if you're in front of a room full of people presenting your budget and you say, I've got some cool graphs, but I don't know what they mean, I would avoid that line of explaining your budget. That will not serve you well in the course of that.
Well, of course, I worked for John, so I learned some of John's techniques. The best one is when you're in front of a bunch of financial people, and you've got a graph that you really don't understand very well, and you just want to get through it. You go, a lot of small numbers, lines going up, next slide.
Yeah. Suggestion, Keith, good things always go up, bad things always go down. Never mix up the slope, okay? You get in a lot of trouble, confusing people. No, the question, Keith, is and something we grapple with, is if you say, I have knowledge discovery and sort of implementation and then follow-up on knowledge going on in radiology, but I also have it in oncology or pathology and a variety of, at an enterprise level, how would one go about structuring the management of this?
Well, we're living through this. And I sit on committees with John and some other folks that are doing this in different areas and probably even far more challenging areas. And as I listen to their discussions, I sit back and say, okay, well, now I'm really in trouble because my knowledge doesn't look anything like their knowledge. And they're just taking their domain and trying to figure out what does their knowledge look like and how to make it consistent amongst itself. And I wish there was some national group or some book you could go out and get and say, here's how the data needs to be represented, but there just is not. And then you go so far back that you say, is it statistical? Is it rule-based? Is it decision tree? And there's just really no answer. So I think the only goal is to put it in some format that can modify itself on a regular basis, because probably for the next 20 years it's going to have to be modified all the time. And that's why I think we made our decisions backwards to say, well, the only data that we have is the ACR. And so I guess we're going to make our knowledge-based system based on what their data looks like, based on what they generated. And as I say, that's 10 years old. Because if someone had a great idea on how to hold the knowledge and start today, by the time they finished, it probably wouldn't be a great idea anymore. And so that's the challenge. So I think this is, like I say, a very practical approach. We're probably going to find all the mistakes we're making. And then the question is now, how do we collectively pull that information together and do this right the second time around, or the third? Thanks. Yes, sir.
Keith, that was a great talk,
yeah,
as always. And I just wondered if you could speculate, particularly for decision support, where do you think we're going in the next 5 to 10 years or so? I mean, what I would love to do, and we've done a little work at our facility, is to have the equivalent of the radiologist of the day that people have talked about assigning to the front desk. And if you wanted to order a study, you talk to the radiologist or the fellow or resident who is assigned to interact with you.
Right.
And that person would know that every time you order an MR of the knee, it's always been negative, and maybe in a polite way would figure out how to get that information back to you.
Yeah.
Or that person might make some other, there might be an interaction. And so I guess the question is, for us, the next generation that we'd like to see would be an interactive wizard with regard to decision support, rather than saying, well, this may not be the most appropriate study, to, based on the history of studies that you ordered, the type of doc that you are, and what's happened, here's some of my advice for you to consider. And so do you have a programming language, or is there a mechanism with the system that you have currently to allow it to be able to evolve to more of an intelligent wizard system?
We've looked at a number of exactly that wizard systems, particularly for the one for the cognitive prosthesis for radiologists. We looked at like Microsoft's help system and a lot of other help systems that are out there that you can do the wizard questions, load them up in data, and bring them back in. And there's just none out there that are going to be the winners, so we really didn't hop onto any of those bandwagons. The other point that you raised is, when is this going to happen, and what about expert systems? You know, people are still okay to make these decisions if they know the answers. And I kind of liken that to You get on the phone to make an airline reservation like I did to come up here, and you start talking to this person that's very nice but robotic and says, hi, I'd like to get a couple of your information. Could you tell, press 3, 4, and you do that, and you do that, and you do that, and finally a human comes up and starts talking to you. It's the same thing here. I had the pleasure of taking a look at one of the payers' methods for management of radiology, and what they do is the first line is folks that just figure out, who am I talking to? I'm talking to someone in the clinician's office that doesn't know anything about the patient. They don't have any information. They just know it's a C period, T period that I want on this patient. And so they start asking questions. And so that first line of support is basically just gathering information. The next level is they have 400 nurses that triages to. And then they ask more intelligent questions and offer alternatives. And then the next level are 2 radiologists that sit back there and a pulmonologist that sit back there and now have this discussion that's more physician to physician, and it works it through the system. So to that point, I think this system could, one, force some of the information to be coming in more accurately to begin with, so you could probably reduce that first tier. The next tier, possibly you could put some rules in there to either educate the nurses so they're consistent, or maybe even in some instances remove some of their responsibilities, and then possibly in the end stage remove some of the tasks from the radiologist. So I think this is going to be a process that shifts over. And when is it going to be applicable is all based on so many factors that have nothing to do with computer science or medicine that it's very hard to predict. Money and all of those things. So.
Go ahead, Paul.
What about changing the paradigm? Refer somebody to an endocrinologist, cardiologist. It's that specialist that orders the test. What if there were certain things, a little bit like you were saying, that we owed you, but then you would actually pick the most appropriate test?
I mean, this makes the most sense. It's training to figure out it's our job as a radiologist to figure out how to help and order and make recommendations. There's this whole fear of self-referral that, if we do something, we get paid for it, so my God, we're going to do the wrong thing all the time and just make as much money as we possibly can. And, I just don't, there's other issues that are so severe that I think that's something that should be explored. The problem with trying to push this to specialists is, to John's point of it's 50 days to go see a dermatologist. Well, it's about 14 weeks to go see a neurologist. So you're a general practitioner that's got a question on a patient, and you think, well, if I could just get a CT, I could probably get this answer back, but I should probably send them to a neurologist. Well, CT takes 4 days, and a neurologist takes 14 weeks. So a lot of it is just access points into the system. And I don't know if we could even handle the method of experts, radiologists talking to the clinicians and thinking through this.
What this brings to mind is open access, where, again, in this example, if we ordered the ultrasound and the plain film, and then we got to the MRI, which is what we wanted to, we consumed a whole lot more of your time and the access and paired the access for everybody else, rather than getting the answer right the first time. I mean, so it can actually paradoxically improve access.
And one of the things that we've seen through the system and the numbers that we looked at, it's not that we're saying to do a less informative test. A lot of times we're saying exactly what you're saying, cut to the chase. You're wasting your time with ultrasound because I know that leads to a CT and that leads to an MR, so just do the MR. Right.
Any other comments from the panel? Okay, start over here. Questions? Any questions or comments?
For the future, don't you think we should stop thinking about images as a bunch of pixels, but trying to describe in a semantic way the content of the picture and store that, because retrieval would be very much more efficient?
I completely agree. And so the concept of structured reporting for radiologists is hanging out there, and it's been out there. And then there have been at least 3 systems in the industry that are commercially available that have been around for about 5 to 10 years, and their penetration is less than 0.1%. And it's really, I go back to the engineers or whoever it is that was doing design and thought on that. The number 1 rule is going to be it can't slow somebody down. And if the radiologist isn't really necessarily the recipient of all of these advantages. So like voice recognition, poor acceptance as well because it saves the hospital tons of money, makes the radiologist work just a little bit harder. So why would they want to do it? If this structured reporting system even adds 5% or 10% of the time, it's just not going to want to be accepted. And so the challenge would be to either structure it as it's coming in and just ask them if it's right, or to find a tremendously simple way for them to go through a series of pull-downs. And then the challenge, too, is that this structure is always changing, and so you got to keep it current. And the exams change, and the depth and the detail of the exams change. So when you put more detectors on a CT scanner, you see more anatomy, and so now you have to ask different questions and go deeper in the structure. So it's a very dynamic system that you'd have to create. But you're absolutely right.
Glenn?
Thanks for your presentation. Just wondering if you could describe a little bit how the quality assurance process or the quality review process has evolved as clinical decision support has evolved within your organization and amongst your radiologists particularly.
Well, I mean, everyone has to do, for a variety of reasons, quality assurance. And so there are a variety of different ways to do it. One of the things we were hoping was with the advent of the PACS system that now we could allow for kind of double-blinded reads and go back and validate and see that. So we've tried to institute that, and the current PACS systems aren't really well accommodating to those issues. So what we plan to do is to use exactly what we were showing here and try and figure out differences between at least recommendation rates and finding rates amongst radiologists reading the exact same types of procedures. And there's a tremendous variability. And then the next question is, okay, this radiologist is recommending at 5%, and this one's recommending at 25%. Which one's right and which one's wrong? And so this is giving us information that we really need to go back and assess. Just like if you went back and looked at image diagnoses and tried to figure out who was right and who was wrong, because it doesn't always come back that somebody's saying, well, this is a ganglioglioma. No, this is an astrocytoma grade 3. It's usually just very descriptive general findings. So to try and follow that patient to the end and come back and figure out what's right and what's wrong is going to be very difficult. But we have a variety of methods in place that are all very subjective and very difficult to administer for a QA, QC standpoint. And hopefully this will help to objectify that.
Question here.
In the 70s, there has been done a lot of work to transform with the first CT scanners the data to images. Today, we want to go back and say, let's transform the images to data.
Right. Just a different kind of data.
Yeah, because today we consider images as a primitive form of information, more or less. My question is the future of the image in the image itself, or should we transform images based on anthropomorphic models into pure data which are more useful in decision machines and experts machines and to compare patterns and diseases and so on? Or should we find other ways or get drowned as radiologists in our own soup?
Well, I think that's going to be a good segue for Elliot to talk about too. But my thought is, like when Paul showed the air traffic controls, they weren't showing little blips of, radar detection, pulse signals. It was a little plane that was dinking around and animating. And it's the same kind of thing here. If you're expecting humans with a pretty big occipital lobe to be looking at this data, then you should probably put it in some kind of image representation. And if you've got someone trained for about 8 years in human anatomy, it's probably not a bad idea to shove it into that format as well. Because if you kept it in the frequency domain for CT, it'd be pretty tough to analyze. But now the question is, so what do you do next? So do you try and make images look even better, which is really where one big push is going, so 3D. And now you even have to be less expert in cross-sectional anatomy and different things to be able to see things because it's being even more human-friendly. But I think there's going to be a divergence where it's going to become easier and easier to see, but also far and far more analytical in this process. So somewhere things are going to leave, and there's going to be CAD, computer-aided diagnosis on the images, that are going to have to go way back to that raw data, or maybe multiple data sets that the human can't look at all at once to try and come back with numbers. But I bet you that answer is going to get superimposed back onto that image, kind of like you see for CAD for digital mammography today, or for lung cancer. So kind of a tough answer to a tough question, but I think there's going to be both directions.
Questions on the right? No? Helen? Helen was first? Okay, good. Sorry.
Today's imaging modalities are generating huge amounts of data, and it will probably increase in the future. However, the relevant information is still the same that you're looking for. So how do you think the decision support can help in actually getting that relevant information to take the decisions?
Well, the other challenge is going to be, I just touched on, one thing on the last slide was just this thing said molecular imaging. But molecular imaging alone is probably going to add about another 1,000 procedures to radiology, because you're going to have to know the exact moiety that you're giving to the patient is exactly what you're looking for in measurements that need to come back. So I don't think anymore, if you look, since this is futuristic and we're looking 3, 5, 10 years, I don't think that the anatomical data is going to be much value or much deeper detail than it is today. It's going to be functional and genetic information that's on top of that anatomical data. And then the question is, now how do you use decision support systems to add that tremendous complexity, which has got tremendous resolution. So it's not like nuclear medicine where it was just general changes. Now it's very specific, maybe even at the cellular level, that there's an activity going on. And so we're going to have to learn things that we just weren't trained to know years ago. And so expert systems, decision support systems in those circumstances are going to be far more critical.
But even with the anatomical data, with the multi-slide CTs, for example, we have already a huge amount of images,
right,
which is very difficult for the radiologist to look through. So how can decision support just filter out these development parts?
Well, that's another point then. Okay, so now if you had a perfect CAD decision support system, it could say, instead of looking at 40 images, now you have 4,000 images to look at on a chest. And I've already kind of looked through these things for you, and I found these 4 things that are really bothering me. So would you mind going to take a look and adding your human expert opinion on these things that I've found? I think there's going to be systems like that. There's some reluctance to the manufacturers of CAD because of FDA constraints in the United States to create those kind of systems, because you have to go through a big process to demonstrate that they're as or different in their effectiveness of diagnosis. It would be nice if that got relaxed, and instead, just like I do window and level to look at lungs or bones, I could dial up something to let me look at spherical objects or linear objects or cancerous objects or stellate objects. I don't know if that's going to happen or not. It seems like, as I say, to me that's weak AI, because now you can look for feature extraction and not have to make that final decision, but you can just aid in the diagnosis or guide somebody to a certain point in this gigantic image set. So I think that that's an area where we need to explore, and certainly products could prevail in that area.
Okay, thanks for the presentation. It's really very interesting. I think the key here is really the complexity comes from how you capture the knowledge and how you're representing the knowledge, right? And also the knowledge itself in the healthcare, they just lots of them are so imperative. Just like you are senior radiology versus you are junior radiology, you see things very differently. So how are you actually representing those things in your decision support system, first of all? Secondly, is that realistically, everybody thinks that decision support is a very good thing to have inevitably. Once everything goes online, you have to have a system support, decision support. But how realistically they were going to pay for this? Where's the economical driver for the vendors even to jump in to do such thing?
Paul made a very good point. I mean, I can tell you who's probably not going to pay for it, or at least not have this burning desire to do it, is going to be the providers, because their margin is too small and it's going to be very difficult to demonstrate this. But if there was a payer-provider system, as some nations have, where there's a payer that's incentivized to do this and can get a buy-in from at least providers from the college or from standards or from some hospitals that want to participate, now you're going to start to show that this is effective. Because if you could stop the ordering of 20% of exams, that's an awful lot of money that someone can direct toward these type of systems. But that's not going to be money that comes from radiology departments or hospitals. That's going to be lost revenue for them. So it's going to have to come from whoever it is that's taking the money in from the patients and not paying it out to the providers. And so in my mind, that would be the payers. And that's what I see happen in the last few years. And this happened 10 years ago, and then it went away in the United States, and now it's starting to come back again, at least in the East Coast that I see. So that is going to be a challenge.
Questions over on the right? Comments back here? Questions, comments? Okay.
Do you foresee decision support or disease pattern discovery that will use the internet along with Merck and MedPix in the future, being able to do like we do for fingerprint identification, if you know where I'm getting at with that?
To be able to diagnose disease or to diagnose based on image presentation?
Yeah, to assist in decision support.
The biggest challenge, I think, if you break down from a radiologist standpoint, I think there's two main things that they do. They see something, and then they figure out what it is. And so you try and decide, I think, in which part of the decision support you're going to take care of them or provide them this prosthesis. Is in their ability to detect something or their ability to then figure out what they detected. And so with CAD and what we're talking about with mild CAD, you can do things that would help to guide them toward what it is they might have missed or they might have overlooked. And so that's where CAD is growing. But the second part is what we're talking about here, and that is, okay, I've seen something. Now what is it? And there's a variety of ways to represent that. It might not be necessarily that we could then say, okay, I've seen this, submit it into a database and come back to me with what this is, although there are people that are heading in that direction too. But it might be, okay, I can define this thing based on some descriptors, and if somebody's got a image repository with those similar descriptors, I can get back now 20 images and I can say, it's that one. And I've seen people headed in that direction, and I think that's where it's going to go first. So human-guided decision-making on the back end after they do image recognition.
Other questions? How are you going to do this without interrupting the radiologist's search pattern and the intensity of relationship with the image?
Well, that's the point of the voice recognition. So in theory, if I'm talking and I've got this thing over there and I'm just talking and talking and talking, as we were saying last night, it's not just important to look at an image and to have two people look at the same system and the same expert system and give them the information back, because two people see this completely differently. So if I was a trained neuroradiologist or I was a general radiologist and I'm looking at a neuro CT of the brain, I need more help. And how do you figure out, if without being intrusive to that process, how you need more help is by listening to what they're saying. And so if you can sit along and very quickly listen to how they're describing things and listen to where they're going and listen to what they omitted and listen to what they may have tried to say in conflict even within itself. Perfect example is we had a quick system that came in that let radiologists do an entire report, and simple thing. Everyone uses a body of a report that has an impression and an impression at the end of it. They say the word impression. So we wrote a quick little thing that said, if you ever say the word left on the top and right on the bottom, or right on the top and left on the bottom, you're probably doing something wrong. So we just said at the end of that, you have inconsistencies in your report. Take a look. And so from there up, now we can start to add information. Now we don't have to bother everybody to say, check to make sure your left and right is correct. Just the ones that are wrong. So that if you can go deeper into the understanding of the report, you can start to follow even deeper the help that they need, or maybe the mistakes that they're making, or the support that we can provide to them at the time.
The other thing is, you're in a department that has a huge history, we talked about that last night as well, of involvement in this area. To what extent is this ideation shared by your other staff people, the other radiologists?
The radiologists?
Yeah, how many, you're a special case. I mean, how many others really have bought into these concepts or participate in this?
There's different people like different things. So for example, some of the radiologists' grief that they have is that, let's say there's 10 chest radiologists and they're reading CTs of the chest. There is no consistent pattern. This is probably the same at every institution, where if I see a 2-centimeter nodule that I say, if the Hounsfield unit is greater than such and such, then you're going to come back in 3 weeks or 3 months and you're going to get a CT, and if that was positive. I mean, there are protocols out there, but everyone's kind of got the one that they like and this and that. And so what happens is you come and sit down and you're looking at the cases that someone else read, and now you're looking at this and you're saying, I don't agree with that. And now I'm reading this next that was done a week later, and I want to say something different, but I can't be different than my colleagues, so now I'm going to say something I don't feel comfortable with. So for those kind of things and the consistencies that we can provide, everyone likes it. Everyone is very, very frustrated with that as a radiologist. And I think from a training standpoint, it's a challenge because everyone, as you know, my musculoskeletal radiology colleagues say, no musculoskeletal radiologist is reading cases without an atlas next to them. And it's because there's some strange nerve that's running through somewhere that you're trying to always remember. And so those folks, if you can put it up non-obtrusively, they love the concept of it. But it's back to your previous question is, can you do it non-obtrusively? Because the systems today, just the whole screen pops up, the image goes away, and now you essentially have a textbook sitting in front of you, and you have to navigate that. That's just not going to work.
Interesting. Go ahead, quick question. One more.
It's maybe related to the question of Dominique, but I've heard from radiologists that it's very important that the first impression that you get of an image. And what they say is that you never get a second chance for first impression. But do you think that decision support can help in generating that perfect first impression image?
You know, I think there's a couple ways, and I'm curious what Elliot has to say about this too. You know, there's this thing like, you know, the old concept of Aunt Minnie. You know, where how do you know it's your Aunt Minnie? Well, it's because it's my Aunt Minnie. And it's the same thing of how do you know this is what it is, where you just look at it and you just kind of get this feel from across the room that that's what it is. That kind of gestalt processing in the brain I think is going to be very difficult to replicate or augment by decision support. But If now I'm looking at 4,000 images in cine loops of 8 different series, and I don't even know where to start, and my first impression is going to be looking through 20 minutes of just totally normal data, then it might be that my first impression is going to be taking me to that one spot, and I go, oh, now I got to think about over here and over here and over here. So I think in some instances it will aid. In some instances, if it doesn't get out of the way, it's going to get in the radiologist's way.
I found this an excellent presentation, and
Thank
I
you.
agree with about any single word you said. Now, a practical point is that if you use theories and ontologies and so, in general and in theory, the whole thing is undecidable, right?
The whole thing is what I'm saying?
The whole thing is undecidable.
Yeah.
That's a theoretical. You can build a theory and ask a question, but in general it is undecidable. Now, what is an acceptable response time and coming up with a no proof found or no answer found to you? Is it a sub-second kind of thing, or is it something that you can wait for?
I think it needs to be sub-second. I think it needs to be almost faster than you're talking. It needs to be faster than you're thinking. And anything slower than that is almost unacceptable.
That's
and
very important to know.
Yeah, and we've
Okay.
seen that in order entry.
Yeah.
Even if the web is slow, people absolutely hate it, and they'll just
Okay.
write a note and hand it to their staff people. And if radiologists, one of the concepts was if you can do back-end processing on this and bring it back to the radiologist 5 seconds later, you could get a far more accurate analysis of the report. No one would do that. No one would do it. So I
That's
think
a
it's
very
critical to do
important
that.
point
Yeah.
to know. Okay,
Keith, thank you very much. I
Thank you.
appreciate it.
Thank you.